Today we're going to carry on working with y equals mx plus b, again finding the equation of a line and working with that. So let's jump right into some more examples. Write the following equation of a line in the form y equals mx plus b. Do a little color code. So this equation is not given to us in slope y-intercept form. It's given to us in a different form. There's no name for this form of the equation. It is definitely linear. I recognize that because there's no exponent on the x or the y. And that was how we could recognize it, but it's not in the correct form. So again, what do we want to do? We want to get y by itself. So I need to isolate y. I need to solve the equation and get y by itself. So the first thing I'll do is subtract 4x from each side. Again, I'll stick that 4x here in the front, make it a negative 4x, put it right after the equal sign, because the x always comes right after the equal sign in y equals mx plus b. Then I'll divide by 3. When I simplify that, the y's cancel out on the left, and I end up with negative 4 over 3x and plus 8. And now I've got it in slope y-intercept form. If I was asked to find what the slope or the y-intercept were, I could say that the slope is negative 4/3, the y-intercept is 8, and I'm good to go. So we've done ones like that before. Here's one that we haven't done before. We're given 2 points, 1, 5, and negative 3, 13. They're on a line. We want to write the equation of that line. So just to visualize this for a second, imagine or picture these 2 points. So 1, 5 is going to be somewhere around here, right? So I'm just using my imagination as far as the scale goes. Negative 3, 13 might be some point that's down here. With those 2 points, that is certainly enough to sketch a line. All right? I want to find the equation of that line that I just drew. It looks like the y-intercept would be about 0, but I can't just go by my sketch because, it's not accurate. I need to actually calculate what the y-intercept is and calculate what the slope is. How am I going to do that when all I've got is 2 points? This is where we're going to have to go back and use the slope formula that we've talked about in the past. So to remind you, the slope formula is y2 minus y1 over x2 minus x1. This is not a hard formula to use. Pardon me. It's not a hard formula to use if you're careful. The people who don't get it right are the ones who are not careful. You have to be clear on what values are your y's. You have to be clear on what values are your x's. You have to remember that there's a minus sign between them. With a little bit of care, it's not a hard formula to use. What you should always do is label your points. So since I've got 2 points now, I won't just call them x and y. I'll call them x1 and y1, as in the first x and the first y. And I'll call this x2 and y2. Okay? That is not a big deal. X's I've been coloring yellow up till now. At least last lesson I did. Y's I've been coloring orange. That might help a little bit because then you can see that only y's go on the top, only x's go on the bottom. Just put them in the right spot. And the formula, just be careful, find the right numbers. y2 is clearly the 13. That should go first. Minus is part of the formula, and y1 was 5. x2 was negative 3, and then there's a minus that's part of the formula again. x1 was 1, and there we go again. Simplify it. 13 minus 5 is 8. Negative 3 minus 1 is negative 4. We should always reduce. That goes down to negative 2. And that is my slope. Now I'm back to what I've been doing in some of the recent examples that we've had. Y equals mx plus b. Now I know what m is. All right, not a problem. So then I go y equals negative 2x plus b. But I still don't know what b is. How am I going to do that? The way I'm going to solve that is I'm going to use one of those 2 points that I've already used from up at the top, either 1, 5 or negative 3, 13, and I'm going to put them in for x and y. Just pick one of them. It doesn't matter which one I use because they're both on the line, as you can see. Either one will work. So what I recommend is pick the one that's easiest. What makes a point easier to use than another one? Well, maybe the one that has smaller numbers, the one that doesn't have any negative signs in it. In other words, this one looks more appealing to me than the second one. So I'll put 5 in for y, I'll put 1 in for x, and then I'm going to solve this to find out what b is. 5 equals negative 2 plus b. Add 2 to each side. b is 7. That didn't take a lot of work, but now I've got everything I need. Y equals negative 2 x plus 7. Now, I didn't plan this, but as I'm writing it out, some alarm bells are going off in my head. So maybe this is a good chance to check things out and just sort of see, what do you do if you're getting a bad feeling about things? Remember early on I said, well, I thought my y-intercept would be 0 or somewhere around 0. Well, 7 is nowhere near 0, right? So I'm thinking, uh-oh, something's gone wrong. What could be the problem? Let's see, 1, 5, negative 3, 3. Oh, I see what the problem was. I think my equation is okay, but I think my original points were wrong. So for some reason, going back to my original sketch here, I imagined negative 3, negative 13. It was just, a careless mistake. We make those all the time. I make them just like everyone else does. The important thing, though, is to pay attention to when things don't feel right. So I think my equation is fine, but what I should have done, as far as my original line goes, is I should have had negative 3, positive 13, which would actually be a point quite a bit higher. It'd be up here near this E in line, and that means that my graph would have looked more like this. And remember, if this was the point 1, 5, then yeah, my y-intercept should be about 7. And now things make sense to me again, and I feel good about it. So, impromptu, off-the-cuff lesson here. Do pay attention to what you're writing out. Listen to your gut feeling. If something doesn't seem right, all you do is go back and backtrack and just make sure you haven't made any careless mistakes. On to the next example. The x-intercept is 4, the y-intercept is negative 5. Write the equation of a line. Okay, let's graph this one again. See if I can get this one right. X-intercept is 4. So that means where's it across the x-axis? So let's say 4 is about here. Again, I'm just estimating. The y-intercept is negative 5. So that's definitely down here, somewhere around here. The graph is going to look something like this. It's not the best line I've ever drawn, but it gives you the idea. I'm going to cheat a bit and move my point up here. There we go. All right. So I can tell, well, actually, I already know what the y-intercept is because they told me that was one of the things I needed. But I can also see from looking at the graph that the slope should be positive, just like I can see looking back at my previous one that going down from left to right on this one is a negative slope, and that confirms the negative slope I got back for my answer in this one. So when I do my slope for example 3, I'm going to expect m to be a positive number because it's going up to the right. Now, again, I'm going to keep going back to y equals mx plus b. And I know what b is. I don't have what m is. But what do I do with this x-intercept of 4? Well, what I can do is I can remember that an x-intercept is really just a point. That's just a way of showing a point. So if the x-intercept is 4, that's actually the ordered pair for 0. So maybe what I should do then is think of that again as an x and a y and use those in my equation like I've done multiple times before. And again, just put the numbers in the right spot, then I can calculate what m is, in this case, slope. So 0 is my y, m is what I'm calculating, x is 4, plus negative 5. Okay, we're going to tidy it up. 0 equals 4m. Again, we're never going to leave it written as m4. That's really bad form. We'll put the number out front. We're going to simplify those two signs. The plus and minus become a minus. We're going to isolate m by adding 5 to each side, first of all. And then we're going to divide each side by 4. And what we're left with is 5/4 equals m, or m equals 5/4. Again, it doesn't matter which side the variable's on, but now I know what m is. Y equals 5/4 x minus 5. Here's another one where we are given 2 points. This is going to be really similar, I think, to example 2. We don't need to sketch it. In fact, I will not bother sketching it this time because I don't want you to think that you have to sketch it every time. But I do have to find the slope. It is crucial that I can find the slope, that I can properly put numbers in, x1, y1, x2, y2. There's no excuse for labeling these wrong. X's come first, Y's come second, and then x1, y1 is just the first point, x2, y2 is just the second point. There's no excuse for not putting the numbers in the correct spot in the formula either, not if you're, being careful. y2 is clearly negative 3, minus y1 is negative 6. Now this does, it does require you to be careful. We've got y2 and y1, and we've got another minus sign in between them that's part of the formula. So yeah, we have to be careful here. But if we take a little time, it'll work out. Negative 5 minus positive 2. Those are my two x's. If we simplify this, we get negative 3. These two negative signs simplify to give us a plus 6. Negative 5 minus 2 is negative 7. So I end up with 3 over negative 7, or, as I like to write it, negative 3 over positive 7. That is my m. Y equals mx plus b. Okay? Well, m is negative 3 over 7. X and y, again, I've got to find b now. But I've got x and y. In fact, I've got 2 to choose from. As long as I stick with one point or the other point, it doesn't matter which one I do. Which one looks easier? To me, the first one looks easier because there's only one negative sign in there as opposed to 2 in the second one. So I will put negative 6 in for y, and positive 2 in for x, because that is what I see there in that point. Simplify, okay. Negative 6 equals, and again, here's, I'm not doing anything different, but now things with fractions, people don't like that. How do I deal with that? Negative 3 over 7 times 2, here's how I think about it. Imagine that any number that isn't already a fraction can be written as being over 1. So 2 is just the same as 2 over 1. And then when I multiply fractions together, we know that we multiply top times top. Negative 3 times 2 is negative 6. 7 times 1 is just 7. And this is what I've got. All right? We still have fractions. You don't like that? Don't worry. Just be careful. I'm just isolating b. What am I going to do? I'm going to bring that negative 6/7 to the other side, but change the sign as I do it. So it becomes plus 6/7. And in order to add these together, there's different ways of thinking about it. You could think about it as, maybe the easiest way to think about it is to take one of these numbers here, take one of the negative 6 and change it to just get a common denominator. Actually, no, I'm changing my mind midstream here. Let's make it a mixed fraction. All right, let's do it this way. Again, there's not one correct way, but I'm going to go this way. We're going to do this as a mixed fraction. If I want to add these two numbers together, I need a common denominator, which means I need to multiply. 7 can be my common denominator. I can multiply the first one, top and bottom, times 7. And I'll get negative 42 over 7 plus 6 over 7. And then we know that when we're adding fractions together, we just add or subtract the numerators. So negative 42 plus 6 becomes negative 36 over 7 equals b. That's good enough as my answer. But if you like mixed fractions, I could rewrite it as 7 goes into 36 5 times with 1 left over, and it was negative, so I could put that minus sign out front. So that's another way of writing it. Negative 36 over 7 is the same as negative 5 and 1/7. Either way, that is my b, my y-intercept. Let's put it together. Y equals mx plus b. It's been a while for this question, so just to remind you of what the parts were. These were the things we needed to fill in. Well, we knew early on that m was negative 3 over 7, and we just found out that b is negative 5 and 1/7. Or, again, you could have left it as an improper fraction of negative 36 over 7. Same answer. So that one required quite a bit of work because of the fractions, and we had to get the slope, and so on and so forth. That was about as hard as I can make it. But if you're careful, you should be okay with it. Last example for today. Determine the equation of a line that has the same y-intercept, same x-intercept as the x-intercept in this equation, and the same y-intercept as this one here. So we have to go back to what we've done before as far as calculating x and y-intercepts go. Remember, to get the y-intercept, let's just sort of work with what's here. So I'll work with this y-intercept on the left side of the page since it's sort of already here. If I want to get the y-intercept, then I have to let x equal 0, right? When I do that, I'm going to start with 5, and then I'm going to let x equal 0, plus 6y minus 24 equals 0. That's just using this equation here after I've let x equal 0. And obviously 5 times 0 just goes away. I can bring the 24 to the other side and divide both sides by 6, and my y-intercept is 4. So just in case you've forgotten, let's actually draw a picture of it. Again, here's a Cartesian plane. The y-intercept is 4. Right? Y-axis is vertical, x-axis is horizontal. Let's say that this is 4. The reason why we let x equal 0 is because anywhere on this y-axis, if this is the y-axis, the x-coordinate of any point on this axis is 0. So, by letting x equal 0, then we can then find out what the corresponding y-coordinate is. And so, that actually is the point 4, 0. Likewise, to find the x-intercept, I'm going to let y equal 0. And before I do it, I'm just going to show you why, because if this is the x-axis, the x-intercept is somewhere on that highlighted yellow line. I don't know what the point is, but one thing I know for sure is that it's going to have a y-coordinate of 0. So I can go ahead and let that y-coordinate equal 0. So to get the x-intercept, I'm going to let y equal 0 on this equation. So I'll get 3x minus 5 times 0 equals 18. Again, this will disappear, leaving me with 3x equals 18. I'll divide each side by 3, x equals 6. Or, if I want to write it as an ordered pair, 6, 0, right? And so then I've got this x-intercept of 6. And then I can, I know what the graph's going to look like. That's not what they asked me to do. They want me to find the equation of the line. But, since I've already come this far, I might as well go ahead and draw the sketch. So there's the line. Forgot to put arrows on the end, but there they are. So I already know what the y-intercept is. So going all the way back to what I did over here, if y equals 4, that also means that b equals 4, because b is what I use to represent y-intercept. I can see that my slope, if I've done things properly, my slope should be negative. I don't know what the slope is yet, but I can calculate it, because with this x-intercept, I've got that point that I want on the line. So going back over here, this point is on the line, right? The point 6, 0 is on the line, which are made up of an x-coordinate and a y-coordinate. And we've done this multiple times now. I just had to recognize where I was getting the different numbers from for the variables. Y equals mx plus b Okay, fill in what we have. 0 equals m times 6 plus 4 rearrange to solve for m. So 0 equals 6m plus 4. Again, put that in the proper order. Bring the 4 to the other side, change the sign. Divide each side by 6. I've got negative 4 over 6, which reduces to negative 2 over 3 because we always reduce our fractions. And that's the slope that I needed to finish off my equation. So finally, y equals mx plus b becomes y equals negative 2/3 x plus 4.